The Dyson Sphere. This enormous construct has shown up in several science fiction books and TV shows, most notably for me in the episode Relics of Star Trek: The Next Generation, first imagined by author Olaf Stapleton and more formally explored by physicist and mathematician Freeman Dyson in 1960. The sphere could be constructed by a Type II Kardashev civilization and encompass an entire star to capture nearly all its solar output. Contrary to popular belief, the Dyson Sphere wouldn't be a solid shell that encases the star, but rather a swarm of satellites around it. We clearly don't have the engineering skills to pull something like this off, and it's been theorized that it would take the material equivalent of a planet the size of Jupiter to create the satellites. So why am I prattling on about Dyson spheres today? One of the most important and relevant topics that we've discussed here on The Tech Between Us has been renewable energy. Over the last few years on this podcast, we've discussed new materials that make energy conversion more efficient, talked in depth about methods of energy storage, and last year looked at new ways energy is being distributed to where it's needed most. As we were preparing topics for this year, it occurred to me that while we've had great conversations about many aspects of green energy, we've never discussed the actual gathering of energy from natural sources. To help us understand the latest innovations in solar cell technology, we have with us Scott Wharton, CEO of Tandem PV. So Scott, before we begin, can you tell us a little bit about yourself? What's your story?
Thanks for having me. I'm the CEO of Tandem PV, and I would say I'm a serial entrepreneur. This is my fifth startup scale-up in a row. I've been really fortunate that I did two early-stage startups in the voice over IP industry, and they both went public. And then I started the world's first cloud video conferencing service. So I think I had the right idea, but it was a little early.
Okay.
It was 3 years before Zoom. Had an exit for the company. And then after 3 startups in a row, my wife said, would you mind not doing another startup for a while? So I went to a company called Logitech that we all know.
Of course.
And I built an internal startup for hardware video conferencing that went from $62 million to over $1 billion a year. We became the global market leader in hardware that worked with Zoom, Microsoft, Google. And then almost a couple of years ago, I came to Tandem PV to move the needle on clean tech and helping hopefully save the world.
Sounds great. So back to a startup.
Yeah, I'm a junkie, I guess. I couldn't help myself.
So what does Tandem PV do? Obviously, you're involved in solar technology, but from a product and a technology, what is it that you guys do?
So we're making a next-generation solar panel. So we make the panel itself.
Okay.
And we're using a completely new material science called perovskites. It's a good dinner party conversation thing that you can pop in there, or cocktail party.
If I can pronounce it, that is.
Yeah, perovskites. It was named after Dr. Perovsky.
Okay, got it.
A Russian scientist about a couple hundred years ago who discovered this crystal structure in the Ural Mountains. But only about a dozen years ago did people realize that this makes an incredible solar panel semiconductor technology. So part of what we're doing is commercializing this technology for perovskites. And we're making a solar panel with perovskites on top, traditional silicon on bottom. So essentially it's a mechanically stacked solar panel sandwich.
Okay.
And the beauty of that is we can capture a lot more light than either of them collectively. So it's more light, better performance. And we can talk about perovskites, but it's a miracle semiconductor that's better, faster, cheaper.
Wow. Yeah. You usually you get to choose 2 of those, and it sounds like for perovskites you get all 3.
Yeah, that's part of why I was so excited to join this company because, it's a winning combination. The challenges we'll get into, it's a pretty hard thing to do. We've got a bunch of really smart PhDs and a whole bunch of different disciplines. I was explaining to a friend of mine last night that part of what I like about it's got so many different disciplines. Like it's got physics, material science, chemistry, electrical engineering, metallurgy, mechanical engineering. So you kind of need to know all of these things and put them together. It's part of why it's so hard to crack.
Interesting. We'll definitely dive a little bit more into that technology specifically here in just a moment. But let's start at the macro level. Global energy requirements. No secret. I mean, we're using, more and more energy. All kinds of technologies are demanding more from what we currently have today, and even more so. From within the energy industry, where do you see all this going? What do you see as the key drivers? And specifically, where do you see renewables fitting into this picture?
I think one of the things that people don't know is that over the last 10 years, solar technology has gotten 90% cheaper.
Okay.
And along with that, so it's about 99% cheaper than when it started, but only in the last 10 years, 90% cheaper. And I think most people know that batteries have gotten cheaper, but they don't know it's about 70% less. So the combination of those two have really completely transformed the energy industry, where solar used to be this neat little thing that people liked if they were green.
Right.
But now it's actually the cheapest energy source on the planet.
Okay, yeah. It used to be the little nephew you kind of pat on the head and it's like, okay, run along. But now it's really grown up, it seems like.
Absolutely. So just to give you a couple of stats to show you how far it's transformed that I bet the listeners are not thinking about. So last year in the United States, 2024, of all the new energy out in the U.S., 90% of it was solar, batteries, and wind. 90% of incremental energy.
Okay.
And solar of that was in the 60s. Next year, in a year where we're talking about, we're going back to fossil fuels and drill, baby, drill, 93% is forecasted to be solar, batteries, and wind. So it's winning because of the economics.
So this is new energy coming online.
All the new energy coming online. So basically, almost all of the new energy coming online is solar and solar plus batteries. And with all the discussion about fossil fuels and nuclear, we can get into all that. None of that's actually happening. This is all myth.
We'll talk about those myths in a little bit, but all the incremental demands that are being met with solar and renewables. I mean, all the investment in data center power due to artificial intelligence, all that is just really being met through renewables rather than, like you were saying, rather than more oil and more nuclear and so on and so forth.
For the most part, so if you look at that extra 10%, that's natural gas, nuclear, geothermal, offshore wind, all these other things. So it's actually very small. There's more hype in newspapers about what might happen than what's actually happening.
Okay, well, that's interesting. So, yeah, back in the day, and this is going way back, back to the 70s and the 80s, I remember my dad investing in solar technology. I mean, he had a lot of brochures. He was reading a lot. Obviously, the technology, like you had mentioned, is advanced quite a bit since then. But wouldn't solar be considered mainstream or even a mature technology today?
Absolutely. I mean, one of the things interesting about solar is that when you compare it to all the other technologies, it's pretty much off the shelf. You make it in a factory and you can install it in a power plant or at home within a few weeks or months. If you think about natural gas or coal, it takes years to build these things. Nuclear, a decade. So it's
longer than that.
Yeah, so I would say it's the most mainstream standardized technologies that we have, and I think the listeners know that standards usually win, especially because as you have a standard, it can get better, faster, cheaper, and not everything is bespoke, like installing other kinds of power sources. So that's part of why it's winning, is that every year it just gets a little bit more standardized and less expensive.
And describe what you guys do at Tandem. You're introducing perovskite. Would you consider that a major disruptor in this market, or is it more of an incremental advancement?
It's funny. It's almost a little bit of both. So part of why I was so excited to come into perovskites is that we just established that solar is the future of energy, but today. And almost all of our new energy is going to happen in some combination of solar and batteries. And then in the industry, the consensus is that perovskites are overwhelmingly going to be the future. So in some ways, it's a complete disruptor in that it's a completely new material science. So there's no direct line from silicon panels to perovskites.
Oh, okay.
Like you're basically starting with a white sheet of paper. From a technology point of view. But to the extent that it's evolutionary, it's just building on what we're already doing as a society, moving to using solar and kind of building on top of it. So part of why I was so excited about it is that we're no longer in a situation where you have to evangelize to the power companies about solar. Like, they get it. This is what they're doing. So part of what we're doing is just building a better mousetrap. Now, it's a hard, better mousetrap. And we can talk about all the science involved in it if you want to. But it is fundamentally extending what we're already doing. So I like that from a market point of view. You don't need to explain anymore to someone what a solar panel is. And to some extent, our strategy is to just build a drop-in solution that integrates with all of the other electric systems. It's just much more dense and cheaper.
Okay, let's dive into a little bit about what perovskite is. To me, it sounds like a mineral, and it sounds like something we dig out of the earth. But what exactly is perovskite?
Yeah, it's actually not a mineral. It's a crystal.
Oh, it isn't? Okay, it sounds like one.
It does sound like it, but it's a crystal structure that has three different elements, and then you could swap different things out of it. That gives it that unique properties. But it really relates to the structure because you can change the level of perovskites and things around it. So it's a very, very thin structure. Basically, what we're doing is creating an ink that we put on glass, and it's one micron thick, 100 nanometers. So it's about 200 times thinner than existing silicon panels. In fact, it's about 1/100th of the width of one of your hairs. So super, super thin. It does not use any rare earth minerals or metals, and there's no mining involved. In fact, we actually make it in a lab in California.
Really? Okay. Yeah, and that was actually my next question is obviously there's a lot of discussion these days about rare earths and, shortages thereof. So there really is not a shortage of perovskites. I mean, if you guys are able to build it in the lab.
No, there's no shortage of it. It's completely abundant based on abundant elements and materials.
Okay.
One of the things I'm very excited about this is not only do we get to disrupt the solar industry by making something better, faster, cheaper, bring it back to the United States with Silicon Valley innovation. If you think about our energy security, and we've already established that solar is the majority of new power, and I think part of what's motivating me and the team is how do we control some of our own destiny, not in every area, but at least in some critical areas like energy and cars and semiconductors.
And then that's been been the crux of, like you were saying, to increase, domestic energy output.
That's right. So you can talk about oil all you want, but the reality is solar's cheaper. So probably another thing that the listeners don't know is the biggest deployer of solar energy in the U.S. is Texas.
Right. Yeah. Traditionally, the oil center of the U.S.
And yet, they are the largest deployer of solar energy in the U.S. In fact, Texas last year passed California. So with all the rhetoric about California being green, environmentally friendly, and Texas being hostile, Texas is deploying the most solar in the U.S. and wind, partly because I think they have friendly policies on the deregulation side, but partly because they're greedy. It's got great economics. So that's the way capitalism should work, right?
And we've got lots of land here in Texas that's just sitting out there doing nothing.
Lots of land, lots of sun, a growing economy, needing lots of power. So it's a good fit.
Can't beat that. So from a manufacturing standpoint, you've mentioned that, that perovskite is simply this thin ink layer that's laid on top of solar panels. What else goes into the actual manufacturing of a perovskite-based solar cell? Is it just that, or is there other things that are involved?
Well, the way we make this panel is very similar to thin film technology. So there are other thin films that you put down that are different than silicon. In this case, it's perovskites. So it's going to look similar to other thin film solar panel technologies where you take this ink from perovskites, you put it on the glass. Typically, there's glass on both sides to seal it and protect it. And then you've got a bunch of transport layers to move electrons off of the solar panel out into the world. So there's a bunch of layers, very thin layers though, usually in the nanometer, millimeter scale. And the thickest part is really the glass that kind of encapsulates it and puts it together. So I think if you saw one of these things, it would look exactly like another solar panel in every way. Just the difference is instead of using silicon on the top to capture it, it's perovskites plus this silicon off the shelf that we buy in the bottom.
So how did you guys come up with perovskites? I mean, it sounds like a lot of R&D when it was involved. And did you guys partner with one of the national labs? How did you guys come up with this stuff?
Yeah, it's kind of all the above. So first of all, I joined a little less than 2 years ago as the CEO. The founders of the company, Colin and Chris, they both have PhDs in materials science and applied physics from Stanford. So, a bunch of dummies. So Colin actually built the first perovskite tandem cell in the world when he was at Stanford doing his PhD. So that was about 12 years ago. And then Chris, the other founder, has more than 40 years experience in solar at big companies, small companies. So combined, they had a tremendous amount of experience at building solar. And they've been working on this. They started the company in 2016. So it's been 9 years. And it's been a lot of hard work in R&D. Now, they've done it in concert with, we have some partnerships with the Department of Energy, the California Energy Commission, who have been supportive of us through grants, but also various universities like the University of North Carolina, San Diego, University of Washington, et cetera. So it like a lot of things, it takes a village, and we've built on, I'd say, a lot of foundational technology. But this is a deep tech. Like, it's taken a long time just to get it to where we're, it's going to take 10 years before we get our first revenue. So it's a hard technology.
And how far down the road are you guys with commercialization of the technology? I know that's kind of, your role is to come in and, turn it from an R&D project into something that has a steady revenue stream. How far down the road are you guys on that?
Well, we're pretty close now. So we today we have an R&D factory in San Jose, California.
Okay.
And we make about 150 solar panels a week.
Uh-huh.
It's a good amount, but they tend to be smaller because we're doing them both for R&D purposes, not for selling.
Okay.
Also, the tools that you need to build these things, as you can imagine, they're like, it's football field size. Like, this stuff is complicated and expensive.
Really? Okay, I didn't realize it was that big.
They're huge. So today we're making these on R&D scale. We just raised some money that is allowing us to build our first commercial factory in the United States. So we're kind of
congrats.
building that right now. And the plan is that we would start. Yeah, thank you very much. Not easy to do in this environment.
Yeah, absolutely not.
Also, good validation of kind of the team and where we are. And our plan is to start selling these panels sometime in the first half of next year. So not that far away.
Yeah, just around the corner then. I mean, a year
Yeah.
from a technology sense is, that's no time at all for a new technology.
It still feels far enough away, but close enough.
That's it for now. Stay tuned for the next episode as Scott and I dive deeper into the specifics of perovskite and its uses in solar energy capture. Until then, explore more content from Mouser's Empowering Innovation Together series on clean technology by visiting mouser.com/empowering-innovation.